Hello everyone. In today's video, we are going to see distance time graph in kinematics for year 10 and year 11 students. Let's get started. Distance time graph. Distance time graph can be used to find out how the distance changes with time. Let's see the graph here. This is the distance and this is the time you have. This is T1, this is T2 and this is T3. First, we are moving from 0 to A in time T1, and then from A to B we are not moving at all. Can you see that the distance is not changing? We are at the same position. From B to C we are going from time T2 to T3. This is the slope of the distance time graph. A straight line shows that the speed is constant. The slope of the distance time graph will show you the speed. Speed is constant here as we are moving with the same speed from time 0 to T1. This position, when we are not moving at all, a horizontal line shows that the speed is 0. Because you are not moving, when you are not moving, that means you are at the stationary position. That means your speed is 0. We are covering no distance from time T1 to T2. We are at the same position. From T2 to T3, our graph is steeper. What is the meaning of that? The steeper a line is greater the speed. That means my speed is faster than OA because my graph is steeper. The gradient of the distance time graph represents the speed. Distance and speed are examples of scalar quantities. What are the meaning of scalar quantities? Scalar quantities have only magnitude and no direction. This shows you that you are going in 30 km per hour, but they will not tell you in which direction you are going. You may go in any direction. That will give you the speed. Displacement, velocity and acceleration are the examples or vector quantities. What are vector quantities? Vector quantities have magnitude and direction both. If they are saying that you are going at 50 km per hour in the east direction, that means this is the velocity they are talking about because they give you the direction also. Application of differentiation in kinematics. In this video, we are understanding displacement here. Let's see the displacement. Consider a particle P traveling along a straight line such that its displacement s meters from a fixed point O, t seconds after passing through O is given by s is equal to 4t minus t square. The graph of s against t, we have to plot it from time greater than 0, less than or equal to 5. I need to plot this graph here. Let's substitute all the values from 0 to 5 here in this s and first calculate the distance here. When t is equal to 0, let's substitute 0 here. My s will be given as 4 times 0 minus 0 square. This will be 0 minus 0. My s is equal to 0. I didn't cover any distance. If I put t is equal to 1 here, s will be written as 4 times 1 minus of 1 square. This will be written as 4 minus 1, which is equal to 3. S is equal to 3 meters you have covered. In the same way, if you continue substituting t is equal to 2, t is equal to 3, t is equal to 4 and t is equal to 5, you will get s is equal to 4, s is equal to 3, s is equal to 0 and s is equal to minus 5. We need to plot this graph here. Let's plot it here. This is my graph, distance time graph. This is s is distance and t is time here. 1, 2, 3, 4, 5 is the time. And my speed is 1, 2, 3, 4, 5 here. When t is equal to 0, s is equal to 0. So my point is here. When t is equal to 1, s is equal to 3. So this is the point is here. When t is equal to 2, s is equal to 4. So the time is 2, s is 4. When t is equal to 3, s is equal to 3. It is 3, s is equal to 3. T is equal to 4, s is equal to 0. You are again at the same position. When t is equal to 5, s is equal to minus 5. If you can see that here, when t is equal to 5, s is equal to minus 5. You join this and your curve will be like this. This can be represented on the motion line as I have to represent it on the number line here. So this is my distance here, 0, 1, 2, 3, 4, 5 and this is minus 1, minus 2, minus 3, minus 4 and minus 5. When time is equal to 0, I am at the origin. I am not moving anywhere. When t is equal to 1, my distance is 3. When t is equal to 2, distance is 4. When t is equal to 3, distance is again 3. When t is equal to 4, distance is 0 again. When t is equal to 5, distance is minus 5. So you moved from 0, you went and you went till t is equal to 2 where the distance is 4 meters. Again you are coming back because your distance is reducing and it will go to minus 5. At time t is equal to 2, what is happening at this position t is equal to 2? At t is equal to 2, the displacement of the particle from O is 4 meters. What is the displacement? As I told you, displacement has the direction also. You are starting from 0 and your displacement is 4 meters here. When t is equal to 2, the particle stops instantaneously and reverses its direction of motion. At this point, he is taking a turn and he is coming back again to the origin. His speed is reducing. At this point t is equal to 2, we can say that the particle stops instantaneously and he is reversing the direction. At t is equal to 3, the displacement is 3 meters. The displacement is what? Displacement is 3 meters only. But as you can see from here, it went from 0 to 2 and then it is coming back here. The total distance traveled is how much? Total distance traveled. Distance doesn't have the direction. Distance is a scalar quantity. How much distance you covered when time is equal to 3? You started from 0 when time is 0. You went till 2 which is 4 meters and then again you come back here. You covered this much distance. How much is the distance? 4 minus 3. You covered only 1 kilometer more. So the total distance traveled is 4 plus 4 minus 3 which is 1. 4 plus 1 is equal to 5 meters. Total distance covered is 5 meters but the displacement is only 3 meters. Let's see that here at t is equal to 4. The displacement is 0 meters. At t is equal to 4 you are again at 0. So the displacement is 0. But the total distance traveled is how much? You started from here. You went till t is equal to 2. Where your distance is 4 meters. Again you come back to 0 again. That means again you covered 4 meters. The total distance covered is 4 plus 4 is equal to 8 meters. At t is equal to 5, the displacement is minus 5 meters. As you can see that the time is equal to 5. The displacement of this is negative 5 meters. But the total distance traveled is how much? First you covered in the positive direction 4 meters and then again you covered negative 5 in the reverse direction. So the total distance traveled from minus 5 till 4 is how much? 4 on in this direction, 5 on in this direction. So 5 plus 4 is 9 kilometers you covered. So the total distance from the 0 is covered by 4 plus 9 is equal to 13 meters. Thank you so much for watching. I hope you enjoyed my video. Don't forget to like, subscribe and leave a comment down below. Bye bye everyone.